purpose of my lab was to understand the relationship between thickness and the light transmission, transmissivity of various materials. For this lab, you can see that it has a switch that can select the range. The ranges come with obviously a different sensitivity, but also a different margin for error. Just 1 second, let's share my screen here. All right, so here we can see some of the data from my lab. What I did was I set the sensor up inside of a light-proof container that is non-reflective but lined with they used aluminum foil. A huge majority of the light. So the only light coming into this box is through this small controlled size orifice. And then what I would do is attach samples of material. Here I have one. It's this interesting looking lensy plastic cell phone shaped for some mysterious reason. And then I would turn my lamp on, and my lamp was held in a controlled position so that the amount of light going into the sample was always the same. And then I would measure the intensity of light behind the sample. I was also able to do this with multiple layers of a few of my samples. So taking a look at the data here, I got samples of blue shop rag, paper towel, this low density polyethylene vapor barrier. So that is basically a plastic bag that is used to wrap buildings to keep moisture from getting in or out. I had a piece of shiny plastic. By shiny, I mean it looks kind of like foil. It had a physical vapor deposition process done to it. I also had some regular notebook paper. And I had this rubber sheet here. This my desk. I thought that would be a good material to test. You can see that I have calculated here the transmissivity millimeter. So that means basically the proportion of light coming out to the light coming in, or thickness. So if you had a sample of, say, notebook paper that was 3 millimeters thick, it would be this number cubed that you would multiply your incoming light intensity by to approximate your outgoing light intensity. Now, as I mentioned earlier, I do have some data for samples where I could take a test through multiple layers. So I have that down here. I've got it scaled to the thickness of the material in total. And you can see here up at the top, I have 980 lux with nothing in front of the orifice. And so about cut it in half as far as one layer of that plastic. And you can see that on the graph over here. The blue is our vapor barrier. We also have red, which is our notebook paper. Yellow on the graph, which is that yellow rubber I showed you. And interestingly, I have this plastic lens film. I think I showed it to you earlier. That was this green line here. Now, it was only big enough that I could make 3 samples out of it. But you'll notice that the light intensity on the inside of the box was actually higher with 2 layers of that plastic going through it. And that's due to some interesting optical properties of that particular sheet of plastic. That has to do with the shape of the surface and how that's curved in order to capture light. Although I believe the purpose of that sheet was actually to blur light. Okay. So you've seen my data, and I feel like the goal of this lab is more or less accomplished. I feel like I have good understanding of how light's intensity exponentially decreases the further you get into a material. This would also theoretically apply to like ocean or even like a wall or a window on a building if you want to calculate the light coming through. So all in all, I feel like this research is somewhat relevant, and it was very educational